-1s. I'm just going to go over these released items here. I don't know how long this video is going to be. If it's too long, just go check out the PDF. If you get confused, you can come and jump to one of the questions that you're confused about. So let's start this off here. Let me just erase this. It should be here. Yeah, so this could probably just be a relaxed little video here. I don't know, maybe an hour long or so. Hopefully not. It's 20 pages long. So first thing I'm going to do is I'm going to look at all these numbers. Say 125, 25, 5. You have a common base of 5, so I'm going to change them all to base 5. But I'm also going to multiply in that exponent there. So 125 is 5 to the power of 3. And then I have x squared plus x in the top here. Should be a plus sign there. The bottom here I'm not going to change. I'm just going to get rid of the parentheses in my exponents. I don't like them. And I'm going to change the 25 to 5 to the power of 2. And get rid of those parentheses as well. Then I'm going to multiply in these. That 3 to this side, the 2 to this one here. And I'm going to get 5 to the power of 3x squared plus 3x. And then I'm going to get that divided by 3x minus 4. It's like a little commentary. It's like a DVD commentary for these diploma questions. These are fun questions. They've been vetted and made and designed to trick and to, I don't know, just to assess pretty good here. So let's see, we're going to, because they're the same base now, I can divide the two. So therefore I can subtract my exponents. So I got 3x squared. 3x minus 3x is nothing, but then I get plus 4. The reason I get plus 4 is I'm going to minus a negative 4. Okay, and then I get 2x. Okay, now I've made a exponent equal to exponent here, so I can drop my base. Okay. 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 So my exponents must be equal to each other here. And then I just rearrange this. You can see it's already looking promising. You got a 3x squared, like I do. I have a 3x squared. They want to make it equal to 0, so I'm just going to move everything to the other side of the equation now. So I'm going to minus 2x. So the b value is a negative 2, and then I'm going to add over the 10. And you get 14. So my answer is 14, because that's what they're looking for the c value. All right, cool. Oh, I kind of crammed these 3 questions in here pretty good here, so let's hopefully we can get these ones done. They want to know what log AB and log BA are, plus add them together to the nearest hundredth, which probably means I'd have to find out what A and B are. So let's see what A and B are. So in this first one here, is this guy here. I'm going to change that to exponential form. So a to the power of 3 is equal to 8. So that's that piece. And then this one here, I'm going to change to exponential form as well. So 4 to the power of 3 halves is equal to b. So I could solve for both a and b here. For a, I just take the cubed root of both sides and get a 2. And for b, I just do the math. It'd probably be an 8. But I'm too lazy. I'm just going to punch in my calculator here. Oh, no. Should have some brackets in my calculator. Yeah, I got an 8. Okay. Okay, so once we know what those values are, we are just going to put them back into this equation right here, where I have log a base 2 of 8 plus a log base 8 of 2. And we just punch it in your calculator and see what we got. Oh yeah, I got an old calculator. Log base 2. Right. Log base 2. 8. We get 3.3 repeating according to my calculator. Seems like everything worked out pretty good there. So my answer to the nearest hundredth, 3.33. Okay. Oh, it's one of these. It's kind of weird to put a question in here that involved trigonometry. Problem is we haven't done trigonometry yet, but I can still answer this question just because we want to complete this solution here. It has a log in it. That's probably why I stuck it in here. But we need to know what an identity is here. What is 2 sine x divided by sine 2x? And the problem is I don't have a formula sheet near me. I would want one. Just 1 second. Go to my other screen. Let's see what we have here. Here's one. The PDF. Oh, that's kind of ridiculous. Why would you do that? Let me just pause this. All right, so I found a formula sheet here. We haven't talked about identities yet, but this log, sorry, what's inside on the formula sheet, which I'll give you as well, also has a log law, so maybe I should just post that right now. Tells me that sine 2x here turns into sine 2 sine x cos x. All right, knowing that, I can see that the sine, 2 sines will cross off here, and I'm going to be left with log of 1 over cos x, and that turns into log of cos to the power of -1. Okay, I don't like putting the -1 there. Maybe I should put that there. It's not an inverse. Put the -1 on the outside here. That exponent is going to drop down, and I get negative log cos x. So it looks like we'll get a D here. That one's a bit beyond. We haven't gotten that far yet. I probably even won't do that to you guys, combining those 2 units together. Let's see what we have here. It's a pretty hard question. So this next one here, they just want to know what the value of this log, if I know what this log over here is equal to log base A of B, is 1.26. The problem is I don't know what A or B are. I don't have enough information for that. But I do know that log base A of B to the 1/3 is the same as this one. And I could drop the 1/3 down to the front, because that's what our log law says. Oh, and then right here I have a log base A of B. So this is 1/3 of 1.26. And then I just punch that in my calculator. And I get 0.42. And there we go. Pretty good. Here's a nice little partial graph. What they've told us so far is that, remember, a regular log graph has a horizontal asymptote that looks like this, and it looks that direction as well. The horizontal asymptote is usually at 0. And it's going upwards like this, but in this case, this one's going down. You can see that. So there's some kind of reflection going on here. So it looks like A has to be less than 0. So I'm just going to cross off C and D. And it looks like I've moved this many units. Right, so this is my H value, and the H value is a positive number. So remember that this little negative is there already. So if H is positive, that'll leave me within like -2 there or something. So it means my H is a positive number. So I got 8. Cool. Okay. Well, here's a nice little typical log graph or log equation regarding loudness this time. You got intensity, you got a reference intensity. So remember, whenever you talk about reference intensities, you always just, easiest one is just make the reference intensity equal to 1. It could be any number you want it to be. It always seems to work out. During the international soccer tournament in 2010, a noisemaker called a vuvuzela, whatever, I can't remember how to pronounce that. They were all the rage a while ago. Measured the loudness of 127 decibels. The intensity of the sound is 5,000 times greater than the intensity of a lawnmower. What is the decibels of a lawnmower? Okay, so first of all, I got to find out what the intensity of a vuvuzela is. I don't know how to pronounce that properly. So I'm just going to go through that. We know the decibels of this one. L is the decibels. That's good to know. So I've got 127. So you go to 10 log base 10 of I. Okay, so I'm just going to say divide by 1. I'm just not going to write that. So I've got 12.7. I'm going to divide the 10 over. And I am going to, and remember, they don't mention the base 10 here. If they just said log, you assume it to base 10. seem to be nice enough that they just left that there for us. So log, well, I is equal to, I'm going to change this to exponential form, 10 to the power of 12.7. Okay, so that's that one, but the Vousela is 5,000 times greater than a lawnmower. So what I'm going to do is find the lawnmower by taking this one, this is the Vousela one, and divide it by 5,000 because the lawnmower is less than that one. 10 to the power of, I'm going to divide it by 5,000. Okay, I'm going to get a number. I don't know what that number is, but what I'm going to do with this number is I'm going to put it back in to the equation. 10 log base 10 of whatever this number happened to be. And you can punch in your calculator, so I can go 10 log my answer that I have here, my calculator. And I get 90, 90.01, 90.01 decibels. So it looks like it's going to be C. Cool. Here we have a log graph or logarithmic form. Oh, I want to change the logarithmic form. Let's see which one of these matches up here. So remember, when you want to change a logarithmic form, you want to get the exponent part by itself. So I'm going to divide over that 4 first. Now I'm going to change this to log base A. You can see I have a bunch of base A. This is the only one with the base A in it. So that's probably my answer. This one doesn't work unless I had big brackets all around that. So this would be the case if I had this instead and I want to change it to the exponential form. That would be the base because 4A would be the base here. But that's not what it is. So that can't be it. And I have no idea what's happening to the other ones, but let's just change this. So we go log base A. I'm going to put this into that, and the 3 drops over there. Some of these 2 things could switch their spots. So it does look like it's going to be B. But I could just not even done any work to find that one out. It's kind of weird. You want to know the expression for log base 2 of 90. If I know these are the 2 things over here, and I can see that I have a 3 and a 10, and I know 90 is 9 and 10, and it's also 3 and 3. So I know that log base 2 of 90 is actually 3 squared times 10, right? That ends up being the same thing. That's what 90 is. So I haven't really changed it, but what I can do with my expression now is if I multiply things inside the log, I can split them apart. So I have a plus sign here. And now I have things up here. Log base 10 of base 2 of 10 is B, so I know there's a plus B here. So I'm just going to cross off C of D right away. And then I'm going to drop this 2 down, because the 3 is raised to the power of 2, because that's inside there. And then this is an A, so it's 2A, and then I have the plus B. There we go. So it looks pretty good. It's going to be there. Looking nice. Okay. Okay, so where did these kids go wrong in their simplified steps? And you can see they both got different answers for the same question. And it looks like they both did it wrong because the first recorded error and the first recorded error. So they both did something wrong. I can always see that it's step 1 here for kid. Well, not step 1 for kid here. Step 1 for student B is definitely wrong. When you're cubing this, remember that's just this times this times this. It's the whole distributive property. There's going to be tons of terms here. If I want to try to get rid of this 3, I cannot just simply multiply that in like that. That just doesn't work. So definitely step 1 for kid B. So let's cross off. Oh, I was going to see that definitely made a mistake in step 1. Okay, the other kid here, let's see what his mistakes were. His mistake was when you, okay, so when you added, that was pretty, oh, this is the first step. Okay, so first step's fine, you put these together. So when you add 2 logs, you multiply them together. So that's a good step. So step 2 is good. Step 1 is good. You brought the exponent up to that. That's a good step to do. But the problem with this next step is that this is inside, this x to the 5 is inside of, what can I say, is inside of a function. So this 3 cannot go into here. It's not allowed to do that. So this is not going to turn into a 15. So I'm not allowed to combine those two exponents because I had to get past the log first. So my first error in that case would have been step 3, I would say, for that one. Okay. Usually in those kind of questions is that where do you see the mistake? Like it could be the step happened between 2 and 3, but we see the mistake in step 3. The number function which have a vertical asymptote of x. So these are the ones that have a vertical asymptote but haven't moved. So remember, a log graph looks like this to start off with. It has a vertical asymptote of x equal to 0 already. So if I haven't moved side to side, my vertical asymptote is going to be the same. So which of the functions above has a vertical asymptote of x equal to 0? Oh, the number of functions. I want to know what the number are. And there's 1, 2, 3, 4, 5 functions here. Definitely not all 5. The reason it's not all 5 is because this graph here has moved left 2 units, which is going to change my vertical asymptote to -2. So definitely not that one. This one's only moved upwards. That's fine. Up 2 units. That's okay. Here's a horizontal stretch by a factor of a half. That's fine. Vertical stretch by a factor of 2. That's fine. This one just didn't move at all, so that's okay. So there are 4 graphs here that have a vertical asymptote of 0. Only thing that's going to change a vertical asymptote is side-to-side motion. Now here's an exponential graph. It looks pretty good. You should also determine the following characteristics. 2 of the characteristics that remain the same. If I vertically stretch this, when this function f of x, this whole thing, this graph right here, that function is stretched vertically by a factor of a, not reflecting it. A is greater than 1 here. Which 2 characteristics will remain the same? Just 1 second. Just gonna check the email. Oh, okay, cool. So which 2 characteristics will remain the same here? Let's see. Vertical stretch. So I have a horizontal asymptote here. But because that horizontal asymptote, I'm doing a stretch to this graph. Because the horizontal asymptote is not on the vertex, or sorry, the axis, that's going to get stretched downwards by a factor of a. It's going to be times by a. This point is going to get stretched upwards by a factor of a. So it's definitely not the y-intercept. It's definitely not the asymptote. Okay. Definitely not the range, because this whole line moved downwards. So rather than being everything above this line, now it's going to be above some other line that's down here somewhere. Okay, so definitely not the range. The only 2 answers we have left here are 1 and 3, and it says there are 2 of them. And it kind of makes sense that the domain's not going to change. And the x-intercept, because that's on this line here, if I do a stretch about that line. That's one of my invariant points. Okay. This is a fun little property here. I like this one. So I want to figure out what x is in this situation, but you also notice that they're upside down. So I can't just drop the bases. This is a over b, and the other one's b over a. So this side over here, I'm not going to change. This one looks pretty good to me. I'm going to leave this one alone. Now I'm going to change this one. What I'm going to do is I'm going to flip it over. Plus, I'm also going to pull that 3 out. So I'll pull out the 3 first. How about that? Okay. I'm going to multiply that 3 in eventually, but what I'm going to do is I want to flip this over so it looks the same as the other ones. I'm going to change that exponent to a negative there. Okay, cool. Okay, what I'm going to do is I'm going to multiply this into the brackets. And I'm going to drop the base at the same time. Otherwise, I'll just do that. Why am I blanking on that? Okay, I'm going to add that over to the other side. Now I'm really blanking for some reason. There's a 9. X equal to 9 over 5. Oh. Oh, yeah, this would be a -9 there. Sorry. -9 over 5. There you go. Cool. Looking pretty good. Okay, so you don't quite have a equation here, but we got a couple key words here. This is increasing at a rate of some percentage, and a percentage, I'm just going to change that right to a decimal. So what I know about this equation, y is equal to ab to the power of t over p, that's, or it could be a c in there, I don't know, is the a value is my initial amount. My initial amount happens to be 16,000, so I'm going to put 16,000 here. My b value is going to be 1.026. If I don't put the 1 in front, this is going to be decreasing, but it's increasing. And then t over p, and it says this is per year. I want to know how many years, so it'd be over 1 right there. You could just put a 1 there if you want. Okay, that's equal to y. And now I want to know when this is equal to 20,000. So I'm going to go 16,000 times 1.026 to the power of t. And then we're going to start rearranging this. You can graph it. I'm going to use logs to solve it because that's something we know. So to do this with logs, you could take the log of both sides as is. Nothing wrong with that, just makes it a little bit more complex. What I'm going to do is I'm going to divide over the 16,000 first. So I divide over the 16,000 first, I get 1.25 power of t. Take the log of both sides. Because I got an older style calculator, that's what I'm going to do. You can change it to log form, but I'm going to take the log of both sides because my calculator is older. Like you could have done this as well. My base is that, so I can say log base of 1.026. 1.25 is equal to t, and then solve that. I'm going to have to do it this way, so I'm going to drop that t down. And then I'm going to divide over the log point. Oops. Divide over this log to the other side. Log 1.026. Essentially, that's the same math. If you remember your log change base form, I can change the base of any log. But I'm just going to do it this way for my calculator's sake. What does it say? To exceed. Okay, so 8 years is not going to exceed it. So it's 8.69 years, right? It's going to take 9 years to exceed it. 8 years won't get me to the 20,000. So I can cross that off. These other guys are way too much. All right, I want the minimum number of years. Cool. What is y squared in this situation? So they want to know what y squared would be, but first of all, let's find out what y is. So what I'm going to do is I'm going to change this into exponential form. So I'm going to base x. I'm going to switch these two things, so that, and then what I'm going to do is I'm going to square both sides. That looks like an answer right here. Yeah, this one. Pretty easy. Not too bad. Another word equation here, but this time it's about a log form this time. So I'm just going to make sure my cursor doesn't jump around here. In 1906, earthquake in San Francisco was 7.8. What is the magnitude of earthquake that is 158 times less intense than that one? Less intense. Times less intense. So he's going to have to find the intensity of this earthquake and then find the magnitude of the earthquake. So what's the intensity of the San Francisco earthquake? Let's call that SF. Well, remember for intensity-wise, you always make your intensities, just make it a little bit easier. Let's just say it's 1. So 10 to the 7.8, that is the intensity of that one. The intensity of an earthquake, just a random earthquake, let's just call that a random earthquake, is going to be this number divided by 158, because it's less. Okay? Then what I'm going to do with that number is make this equal to 10 to the power of m and try to solve for m. So I'm going to change this into log form so I can take the log of both sides because it's base 10. My calculator allows base 10. This will be log base 10 of 10 to the power 7.8 divided by 158 is equal to m. So you can switch these two spots. And now I have that. So I got log base 10, 10 to the power of 7.8 divided by 158. And I get 5.6. Cool. Well, very good. What page are we on? Oh, page 9. We're cruising along here. Now, some of these pages only have one question per page, so that's pretty easy. We want to know what the value of k is here. If I know one point of this graph, can I find the value of k? Okay. So I'm going to use this one point of the graph here to maybe find out what b is in this question. Because if I put into this equation, if I put a 2 into this equation, I need to get out a 1/3 because this is an x and this is a y. So I can rearrange this and say b to the power of 1/3 is equal to 2. So I can switch those two spots. Now I need to get rid of this 1/3. One way to get rid of a 1/3 is to multiply by 3. So that means I'm going to cube both sides. So b is equal to 8. Okay, so that answers what b is. Now I'm going to go to the other point here, log base 8, and I'm going to put in the k, and I should get a 2 out. This is x and this is y again. Okay, and I'm going to change this to exponential form. So 8 to the power of 2 is equal to k, so that's going to be 64. Cool. What is the value of x in this situation? Well, to do this one, I'm going to have to change this to exponential form eventually. But that means I'm going to have to use my log law here. So I'm going to subtract these two pieces. Okay. I can reintroduce a log here if I wanted to, but I can also just change this to exponential form. And this is 5 to the power of 3 is equal to x over x minus 2. Okay, 5 to the power of 3, 125, right? Yeah, 125. I'm going to put this up a little bit higher. I don't know how this is going to play out later. Okay, we're going to try to solve for this x. I'm going to take this denominator here. I'm going to multiply it up to the other side. I'm going to multiply that in. I don't know why. That times by 2. Okay, and let's keep on going here. I'm going to subtract over that, so I get 124x is equal to, I'm going to add over the 250. So I'm really just switching those two spots there. And then I'm going to divide this number by the 124. So I get 2 point to the nearest hundredth, 0.2, because it rounds up. Nice. All right. Rural towns experiencing changes in population due to the construction of a new highway. One's going down, one's going up. Not bad. So describe the significance of each numerical value in the equations above. Okay, so the 4,000 and the 2,500 are both the initial populations of towns A and B, and if you want to say respectively as well, because they are in that order. What we could say about this, the 0.97 means the population is decreasing, or decaying. I wouldn't say decaying, that's just kind of morbid. Decreasing by, not by 97%, but it's decreasing by 3% each year. Because I think T is in years, right? Each year, yep. While the 1.05 means an increase of 5% each year. There you go. Oh, sorry about my writing there, but whatever. Looks pretty good. I think that's all the numbers that we had to talk about there. Good. Algebra determined the number of years that will take the population of the two towns to be the same. Okay, so they want to be the same, so let's make the equations equal to each other. So 4,000, all right, is equal to the 2,500 number. Okay, so I want to know when they're going to be the same. So when are, what are these two graphs going to be the same? You can graph them out, but it says algebraically do this. So what we're going to do here, oh, okay, so I'm just going to move everything to the t's to one side. So I'm going to just kind of make fractions here. So I'm going to divide the 4,000, I'm going to divide that by the 2,500. I get 1.6. So I'm going to go 4,000 divided by the 2,500. I'm just going to leave this side alone for now. Just show all my steps here. So what you should do, and then I'm going to divide over the this one here to this side. So this ends up being 1.6. Right there. Okay. Now, the cool thing about this is they have the same exponent. Because they have the same exponent, I combine their bases together by dividing them, and I can go like this. I wonder if I get a nice fraction out of this or not. No, I don't divide it. I could divide those two, get an ugly decimal, so I'm just going to go math and enter. You notice that there's the same numbers, but they're, rather than being decimals, they just times by 100 each. So I can combine them together to look like that. I want to solve for t algebraically here, so I can change this to exponential form. I can take the log of both sides. I'm going to have to do, I'll show you both, but I'm going to have to do the log of both sideways because my calculator is limited. So I'm going to take the log of both sides here. Okay, drop that t down. And then divide both sides by the log there. Or you could have just changed it to exponential form by saying log base, this is a really ugly base here, of 1.6 is equal to t. So both of those would get you the same answer. Here, I'm just going to write out what I'm going to type in my calculator. That log looks really weird. Okay. Cool. So log 1.6 bracket and divide by log whatever my answer was there previously. So t ends up being 5 to the nearest 10th. 5.9 years. Nice. Pretty good. Both fit perfectly. Oh, we're doing an inverse here. Okay, so it's reflected in the line y is equal to x. And remember, this is inverse. So you're switching your x and y's. So this becomes x is equal to 3 to the power of y plus 2. You notice that they made it all y is equal to here. So I'm going to change this to log form. So this is a log base 3 of x. And on this side, we drop that down. The two things kind of switch their spots. And then I am going to minus that 2 over. Pretty good, so I'm going to go with A on this one. Yeah, it's nice. Oh, it's a kind of crazy one. Looks kind of crazy, but we can simplify certain things like this one here, log B of B is 1. This one here, log 1. Log of it, 1 is always 0. So that's 0. So I can just get rid of those two, start off pretty easily. The rest of these you can just punch in your calculator. Yeah, okay, but maybe I won't want to. Let's look at this first one here. So they're just asking for what is 5 to the power of question mark is equal to 625. And the question mark there is 4, right? Yeah. So this first one becomes a 4. This one here saying 3 times something. I won't remember the 3 for now. They're asking for, just for this piece right here, it says 7 to the power of something is equal to 49. Oh, wow. In my mind, I knew it was 2. 49. So this ends up being a 2, but I'm timesing it by the 3 in the front, so it ends up being a 6. Okay? And this one is saying 2 to the power of something is equal to 1 over 16. I could change the base on this other side, so it ends up looking like this. 16 is 2 to the 4, right? Yeah, 2 to the 4. So 2 to the 4, so this is 2 to the negative 4. So my little question mark there is in negative 4. Okay, and I'm just going to add these all together. Add. Yeah, I'm going to add them all together. So 4 plus 6 plus negative 4 plus 1. And I get 7. So I'm going to add all this. I'm going to add the 4, the 6, this. I'm going to add the 1. I'm going to add the 0. And I get the 7. Okay, we're going to change this to exponential form. But before I can change it to exponential form, I need to get the log by itself. So what I'm going to do is I'm going to minus over the 5 first. Then I'm going to divide by m. Then I'm going to go p to the power of m, or q over q minus 5 over m is equal to n. Okay, so we don't have, none of these quite match, but you notice that none of these have the over m part. So to get rid of the over m part, I would raise all of these to the power of m, so that these, when you multiply those two exponents together, the m's reduce out. So I'm going to have p to the power of q minus 5 is equal to m n to the power of m. There you go. You're pretty good. Well, they're both raised to the same exponent here. So since because they're raised to the same exponent, I can follow that same rule we had in the previous question. They have the same exponent. We can combine what's underneath them. So this becomes 9 log to the power of x. That's what that becomes. Okay, doesn't quite match anything that's here. That's a shame. So it's not this one. And it doesn't seem like it's going to be this one. It's got to be one of these 3 ones here. The reason behind that is because this is 3 squared. Maybe I shouldn't have combined them like that. Log x, and then this is 2 log x. You can just multiply those together. Ah, I see. Then this becomes log x squared. The very key is, where is that square? The square is on the x. It goes. One of the laws is that this goes into the operation. It doesn't just square the whole thing, it just squares the x. So it's going to be a. Now I'll write this as a single logarithm here. To do that, you got to get rid of all the coefficients. This is going to be x squared here first. This is going to be z to the half, and this is going to be y to the 3. Okay? So you can see a bunch of square roots on the z there in the answers here. Like there's a square root here, a square root here. So it's probably going to be one of those. It's probably not going to be b. Let's just double check that. So this is going to be x squared, and the square root of z is going to be in the bottom because you're subtracting it. You're going to divide. Okay. And then when you're going to multiply, you're going to, or when you add, you multiply. So that's going to end up being on the top. There you go. So that would be a situation. The reason you probably get C is if you did this piece first, which you're not supposed to do. You always do your order of operations from left to right. So I don't see why you would go one way versus the other. I don't see why you'd go backwards. Sorry. Okay. Let's see what we have here. One question. Oh, we're on page 13 already. We kind of slowed down a little bit here. Let's see what we can do with this next one here. Determine the value of log base 3 of 9ab squared. Oh man, that's crazy. We're going to have to find out what a and b are. We're going to find this value. So this first one here is going to be 3 to the power of 6 is equal to a. So that's just changing into exponential form. So 3 to the power of 6 is 729. That's what a is. And then we're going to do the same thing here. It's going to be 3 to the power of 5 is equal to b. 3 to the power of 5 is 243 is equal to b. Now, that's pretty easy. Now we're just going to plug this into this equation over here. To make my life a little bit easier, what I'm going to do is I'm not going to write the big numbers in. I'm going to write the exponent numbers in. There's a reason for that. So 9 is 3 squared. A is 3 to the 6. And b is 3 to the 5, but that's also being squared. Okay, so what I'm going to do is I'm going to simplify this down as much as possible. So it's just 3, 2 and 6 become 8. 3, this is being squared there, sorry, it's 10. So this is going to be log 3, 18. And I'm going to drop that 18 down to the front. And log base 3 of 3 is 1, so this turns into an 18. So you can do it that way, or you can just plug it all in your calculator. Really, I'm just trying to avoid using my junky old calculator here as much as possible. Where did he first record a mistake? Where did he write the first mistake here? Okay, so the first thing you'd probably want to do is raise that up to here. So you're going to multiply those two exponents to get an 8. That seems right. Raise the 3 up. You left the negative behind. That's fine. Get a 6 and raise this one up. Get a 12. So this seems pretty good. So step 2 seems pretty good. Then he made a mistake right here. That's step 3. Now the reason he made the mistake is what we talked about in the previous question, like 2 questions ago. Order of operations. So what he's going to have to do first, he's going to divide these two. And then he's going to multiply. So that x to the power of 12 is actually in the numerator, not in the denominator. So he did this first. He put brackets around that and said, okay, let's multiply those together and then divide these. That's not what he did. That's not what you're supposed to do. You're supposed to go by order of operations. So this would be the correct way to do this. And then if I want the correct answer, might as well 8 plus 12 minus 6. X to the 14. Yeah. It should be log base A, but I'm not too concerned about that. The equation of the asymptote of a log graph. So remember, our log graph's asymptote starts off at x is equal to 0. The only thing that's going to change it is the side-to-side motion. And here I'm going 3 units to the right. So that means my asymptote is going to be x plus 3. All right. Yeah, I just want to make sure it wasn't harder than that. But okay. She sketched this graph and that graph. And she drew the asymptotes using the dotted lines. Where do they intersect each other? So if I were to sketch the 2 graphs, one graph would have an asymptote. Oops, sorry. The log graph, I should say, would have an asymptote at x equal to -3. I don't know exactly what the graph would look like, but that's that one. And this one over here would have, because it got moved up 3, and we're in an exponential graph, it's a horizontal asymptote at 0, and the only way to move that is to move it up. Yeah, it looks like it's supposed to go like this. So like that. This is where we're looking for. We're looking for that kind of intersection point there. So it's going to be -3, 5. There you go. Good. I don't know where the 7 came from. Weird. Oh, I see. They switched the 2 things there. Yeah. All right. For this graph, the domain. Well, to find out the domain of this log graph, I got to find out where its asymptote is. Before I could do that, I probably want to factor this out. So it looks like that instead. So I know that this graph is moved 4 units to the left. My graph has not been reflected, so it's still going to go this way. Well, that's key because they all are greater than signs, but it's going to be greater than -4. Make sure you factor out that 3 first before you try to find out its horizontal translations. Oh, we're getting there. Page 15. Okay. Oh, the y-intercept of this graph. Well, the y-intercept of this graph is pretty easy. To find the y-intercept, you make x equal to 0. So a to the 0 plus 1 plus b, a plus b. Bam! There we go. That's pretty good. The solution to this equation. To do this one, you got the same base. I'm going to change that 8 to 2 base 3, to the power 3, sorry. Okay, I'm going to change this to 2 times 2, or to the power 2, sorry. 2x minus 18, and on this side I get 9x plus 12. I can drop the base here, because they both have the same base. The exponents must be the same. Start subtracting things around. So I'm going to minus over the 2 to this side, the 2x. I'm going to minus the 12 over to the other side. I should get -30. And I'm going to divide over the 7. Look at that. E, looking pretty good. Hopefully I'm not going too fast and making mistakes. Solve this equation algebraically. The solution, solving the equation algebraically, the solution to the nearest 100. Nothing stops you from solving this graphically. But anyway, let's solve this algebraically, because that's what it says to do for some reason. You know why you just can't graph both sides? Maybe if I graph both sides, I can get a graphical glitch and not have the proper 100th position. So what I'm going to do, again, I'm going to take the log of both sides. So I take the log of both sides. Okay. I'm going to drop my exponents down to the fronts here. Okay. And this would be x minus 3. And this would be log 1/5. Okay. Okay, now we're trying to get the x's by itself. This is where it gets a little tricky if you try to do this algebraically. So what I'm going to do is I'm going to divide the log 3, or I'm going to divide the log 1.5 to one side. So I'm going to divide the log 3 over. So it looks like this instead. I'm going to just write underneath the other log, because that log then can combine together with the changed base, this to be log base 3 of 1/5. Okay. You didn't have to do that. That's fine. What I'm going to do now is going to multiply the log into the brackets. So I'm going to get x times the log base 3 of 1/5 minus 3 times the log. I'm going to move my head here. So okay, just scroll upwards. Base 3 of 1/5. Okay. Pretty hard so far. Okay. Now I'm going to move all the x's to one side and all the numbers to the other side. So this 1, it really doesn't matter. I'm going to go 2x. I'm going to go minus x log base 3 of 1/5. Okay. It's probably so far the strangely hardest question of this test here. Okay. Now I'm looking at this, they both have an x in common, so what I'm going to do is factor that x out. And just rewrite this side. It can look like a K for some reason. And then what I'm going to do here is I'm going to divide everything that's inside the brackets, or the parentheses here, to the other side. Hopefully I did this right. What I'm going to do is I'm going to graph this afterwards. See if these are the same. Just a good verification tool. Make sure I did it correctly. Okay, So you pull out the graphing calculator, and you start punching things in your calculator, see if this works. That's in the numerator. 2 minus the log of 1. So I have to do this a little bit differently because my calculator doesn't do log basis. Okay. So what I get here is x to be 0.98. Okay. Now I'm going to pull up my calculator here. I'm going to just graph this originally before we even started it. So 3 to the power of 2x plus 1, and then 1/5 to the power of x minus 3. That looks pretty good. I'm going to zoom standard that. See what my graphs look like. So I should have one increasing graph, one decreasing graph. I can't quite see the intersection point between the two because it's a little bit high up there. I'm sorry, you can't see what I'm typing in my calculator here. I'm just doing a verification to see if we did this correctly here. So I just got to change it. I don't see my graph here. There's one graph. There's the other graph. Oh, I can't quite see that yet. I'm just going to go crazy on my Y max here. Okay, so here's my two graphs. Let's see what they look like here. There's one graph. You can kind of see that. Oh, and now I can see the intersection point. Nice. And then I'm going to go second, trace, intersect, enter. Thinking. And voila. You can't see it's backwards as well, but 0.979. So it's 0.9. I don't even know why we did that algebraically. Oh my Lord. Should have just did it graphically. Okay, whatever. Let's solve this one here. Solve for x. To do that, you probably want to change it exponential form, but to do that as well, I probably want to use some of my log laws here and combine these two things together. Because I'm adding here, I'm going to multiply what's inside the parentheses. I'm going to change this to 7 to the power of 1 is equal to x plus 1, x minus 5. So I can just do my exponential form there, switch these two sides. 7x squared minus 4x minus 5. So that's just me using the distributive property there. Make this equal to 0. Oh my Lord. It's too early in the morning. Can't see it, but it's 9:30 in the morning right now. Hope you guys are up and studying and working hard as well. Minus that over. Okay, and then hopefully I can factor this. If it multiplies out to 12 and adds to 4, that would be 6 and 2 probably. 6 and 2. It's going to be a negative. There we go. So x would be 6 or negative 2. But then you want to verify that. 6 looks like it works. 6 plus 1 is 7. I can take the log of 7. That's fine. 6 minus 5 is 1. I can take the log of 1. That's fine. It actually works out because log of 7 is 1 plus the log of 1 is 0. So 1 plus 0 is 1. So 6 works. I'll do my little verifying over here. Verify. Okay. So log 7, 6 plus 1 plus log 7, 6 minus 5. So this is log 7 of 7, which is a 1. This is log 1, which is 0, which adds up to 1, which is what it should be. Okay, now negative 2 is not going to work because I can't take the log of a negative number. You're going to get negative 2 plus 1, you get negative 1, just falls apart. It falls apart in the other one as well. So let's get rid of that. My extraneous solution. Another earthquake question, very similar to the previous one. This one says it's more intense this time. Oh, this one is an earthquake measurement is this many times more intense than the other one. So it's actually, you're dividing again. Remember, you can make your references equal to 1 to make these questions a little bit easier. So the first earthquake, yeah, so let's call this earthquake 1 here. Let's just try to find a good name for it. 5.3. Earthquake 2 is the same one, but divided by 125. And then I'm going to put that into this equation. Starts on a slant there. And take the log of both sides. Okay. So the second earthquake has a less intensity according to this, what the worry of that is. So that's why I wrote it that way. So the log of this divided by 125. The Richter scale intensity here to the nearest tenth is 3.1. Awesome. Population of a particular town is increasing. Does it increase? Average rate of increase. Yeah, okay. So it's increasing from one point to another. So from 8 to 16. So okay, cool. Is it cool? Yeah, so what I want to do is I want to figure out where I'm going to put in these spots here for this equation. So it starts off initially at 1,500. It ends off at 32,405. The problem is I don't know what this base value is, but I do know how many years have occurred. Okay. And we have to go through 9, 10, 11, 12, 13, 14, 15, 16. Okay, 8 years. I guess we could just subtract the 2. 8 years. And we just want to solve for B. Okay, so what I'm going to do is I'm going to divide over the 15,000 to the other side. So I get 2.163 repeating here. B to the power of 8. No, just take the 8th root of whatever number this happens to be. So the 8th root of this number, I can go 8 here. So 1.10, which is technically 110%. That's not my answer, right? My increase is only 10% per year. The 100 just makes sure that you keep the same percentage from before, and then you add on 10% each year. So it's going to be a 10% increase. I like how they threw that one in there. Oh, I don't know what page we're on right now. 17, we're almost there. Okay, guys, we're almost there. Got this. Jordan needs $6,000 to go on his family trip. He's able to make an investment, 8% per year, compounded semi-annually. Ooh, that's good. So every half a year, how much would he have to invest so that he has enough money for his trip? In 3 years. Okay, so I need to fill this equation out. Well, actually, I need to find out what A is. This here, because it's compounded semi-annually, is going to have to be 1.04. So this turns into 0.08, but I have to divide it by 2 because of the semi-annual part. Okay, my exponent is going to be t over 1/2 because of the semi-annual part. Semi-annual stands for half a year. Because T is in years, the period is every half year this happens, right? Okay. He needs $6,000. So he needs $6,000 on this side. This over here. I'm just going to rearrange that. Remember, you divide by a fraction. You take the reciprocal and multiply it up. I need to do this in 3 years. So I should probably put in a 3 there. Okay. So 1.04 raised to the power of 6 is, actually, I'm just going to write that there. And then I'm going to divide it over. $6,000 divided by this number. He needs to invest. Right now, if he wants to make this trip, that's $6,000. He needs to invest $4,741 to the nearest dollar. Yes, so $42 to make this work. Pretty good. The point 3p is on this graph. The corresponding point on this other graph that has been moved around is what? Oh, it's just a transformation question. That's pretty easy. So I'm just going to make this equal to y first. And then I'm going to look at the mapping notation, see what's happening. So my y values, oh, that's not too close to the bracket there. My y values are going down by 3. My x values are also going down by 1. Cross those off. There you go. So I started off at 3, went to 8. So 1 less of 3 is 2, 3 less of 8 is 5. So it's 5, 8. Pretty cool. What are you doing for this one? We probably shouldn't have this one because it talks about cosecants. Let's just get rid of this one. We'll come back to this cosecant one when we get to trigonometry. Yeah, we haven't done trigonometry. We'll just ignore this for now. Okay. Now, yeah, we'll just come back to that. I have to make sure that remind myself. I'm just going to write that down here. Just 1 second. Okay, back. Let's see what we're doing here. They want to know what the inverse of this graph is. The y-intercept of the inverse of the equation. So to find out the y-intercept of this, maybe I should find, I can either find the inverse of it and then do that, or I can find the x-intercept of this graph, and when I do the inverse, x-intercept becomes the y-intercept. Either one. So if I want to say find the x-intercept of this graph, to find the x-intercept, you make y is equal to 0. Okay. And then rearrange this slightly. We have to solve for this x value up here. And I gotta change it. Oh, gotta change the log form. So log base of 1/3 4 is equal to x. Eventually, I had to do logs anyway, so you could have just did the log form and then found this as well. Log 4 divided by log 1/3. Yeah, negative 1.26 something, something, something. That's what I did. Actually, probably could have just graphed it, found the x-intercept, and then used that as well. Anyway, lots of different ways to do this. I like that way. Yeah, I'm going to go with that way. Okay, I was thinking about another way to do this, or show you the other way. Let's see what we have here. Oh, it's a tricky one. Oh, all in terms of y's and x's. This is a weird question. That's fine. Now, it's very similar to one that had that 90 before. I could split this log 100 into 100 times m squared times m squared. I can change this 100 also into 5s and 4s, I guess. That's what they have here. They have some 4s, and they got some 5s, so I can split this up into, what can I change that into? Yeah, I could definitely do that. Yeah, I'm just trying to find some of the better numbers to do, but let's say I could change this to a 4 times 5 times 5 times m squared times m squared. Okay, so that's what that could turn into. But because of that, I can also separate it. So log 4 plus log base 3 of 5 plus log base 3 of 5 again. You could just put the square, then drop the 2 in the front, which may end up being the same, which would be like saying this, log m squared, because there's 2 of them. I could do it that way too. Okay, and then I can just start replacing things. So log base 3 of 4 is 2x. Log base 3 of 5 is 3y plus another 3y plus 2 times 6. So I get a 12 there. So it's got to be b. But you can also see there's a 6y and there's a 2x in there, so that works as well. Written as a single logarithm. It's weird. I don't know what they're trying to do here. Seems too easy. Log base, log base. Oh, this one doesn't have a base. Remember that you could reintroduce a log at any point, because log base a of a is 1. So I could just put that in there if I wanted to. That's fine. Sorry, this is going to look a little bit crowded because of where I wrote that. Actually, I'm just going to erase that now. I'll put that in there in a bit. This one has an exponent or something in the front, so I'm going to raise that exponent over here. So it's going to be log base a of a to the power 4 and c to the power 4. So you got to raise both those to the power 4 minus 4 log base a of a, like I said before. I can reintroduce this piece whenever I want, because technically it's just a 1. All right? Now let's see what else we could do. Oh, yeah, I'm going to put that 4 up as well. So this is pretty good so far. So I'm going to combine the first two. I'm multiplying them. So I'm going to go b times a to the 4, c to the 4. This 4 is in the way here, so I'm going to raise that up to the top there. Okay, and because I'm subtracting those two, I can divide these two. Perfect. B times c to the 4. There you go. Okay. A system of equations, because I got 2 unknowns, b and c. I have 2 points, 0, 0, blah, blah, blah. System of equations. This is a good one. I think a system of equations should show up at one point. So the first point is saying that if I put a 0 in here, I should get 0 out. Well, this is not too bad, because that's going to help me find, just put b here, what c is really quickly. C has to be 1. Reason behind that, because b to the power of 0 has to be c. Anything raised to the power of 0 is 1. So c is 1. Okay, so now we're done that point. Then we go to the other point here, and I'm going to put in, to find out what the b value is, because I found out what c was. If I put in my x value of 3 over 2 plus the 1 that we found for our c value, this has to be a half. So b to the half is equal to, what is it, 5 halves? Yeah, it's 5 halves. I don't know why I was trying for my calculator. 5 halves. Okay, so you're switching these two sides here to the nearest hundredth. So to get rid of the halves, I'm going to have to square both sides here. So I'm going to actually write that down here instead. Square both sides, multiply the exponents. That's why I wanted to do that, to get to 1. And this is going to be 25 over 4. And 25 divided by 4 is 6.2. 0.25. It wasn't quite a system. It's close. Oh, my last page, I'm here. God, I'm almost here. All right, the value of x. Well, I can see what's happening here. Okay, so first of all, I'm going to simplify this one down. So I'm going to say, because they both have the same base, I can subtract my exponents. So this is going to be a to the power of, I'm going to subtract my exponents of x minus 2x is negative x plus 6, and minusing a negative 6 here. Because you can say there's a plus 0 here. So 0 minus negative 6, so we have plus 6. Awesome. Looking good. I don't know what I'm going to do here. Oh, I see what they want to do. Okay, so now what I'm going to do is this is what y is equal to. I'm going to put that into this equation here. So I'm going to put that into here. So we log base a to the power of x minus 6. Okay, negative x minus 6, sorry. Oh, plus 6 is equal to x. Okay, I'm going to drop my exponent down. Looking pretty good. Oh, I should put the brackets around that one. And then I got log base a of a, that's a 1, so it's negative x plus 6 is equal to x. I could add over the x, get this, divide the 2 over, and get positive 3. It worked. Positive 3. I have no idea what these other ones are about. It's kind of weird. Do we end off an easy one here? Compound annually. What's the percent per year? We're just looking for the b value. Okay, that's not bad. I want to double my value. So I want $9,000 at the end. So he wants $9,000. If I start off with 4,500, I want to know what the b value is at the end of a 12-year period. Okay, so I divide the 4,500 over 2. Take the 12th root of both sides. You take the 12th root, or you could, I might as well just do it a different way here. Take the 1 over 12 on both sides. Those both will multiply together, you get b, and you get 2 to the power of 1 over 12. So that is 1.059. Says to the nearest hundredth of a percent. So there's more decimals there. 5 times minus 1 times by that. Okay. So this ends up being, if I put in a percentage, 105.95, because I want to do the nearest hundredth, so I'm going to round it there, percent. And then I'm going to subtract out the 100%. So my increase, my interest is actually 5.95% per year. There we go. Cool. That's the end of that. Let's save here, and I will post these answers really soon. Bye.